Physics Part 406. The circuit of figure 4.11, or rather 14.11, is called comparator because it compares the voltage applied to the non-inverting ones. And we'll talk more about it as we get along with it. In fact, we'll continue talking about them as we move along with all these details of the subject physics, and we try to establish an understanding of the same. Well, right now I'm in the night vision, and I hope I get clear with the vision here. The circuit of the figure is called a comparator because it compares the voltages applied to the non-inverting and the inverting inputs, and then gives an output that depends on whether V4, V plus, V negative, or V plus. The two resistors of equal resistance provide an input voltage of 3V at the inverting input when the light-dependent resistors LDR is in the darkness, as is the case over here. Its inverting input when the light-dependent resistor LDR is in darkness, its resistance is greater than 10 kF. The voltage at the non-inverting input will be greater than 3V, and the output will be at plus 6V. In daylight, the resistance of the LDR will be less than 10 kF, and the voltage of the non-inverting input will be less than 3V. The output will be at minus 6V. The output therefore depends on the level of light illumination. This output can be made to operate an output device such as an LED by changing the values of the resistors on the potential divider connected to the inverting input. The voltage at which the circuit switches from plus 6V to minus 6V can be altered. Thus, the level of the illumination at which the circuit switches can be changed. In practice, one of these two resistors would be variable resistors. The circuit shown in the figure switches from plus 6V to minus 6V when the level of the illumination increases. By changing round the connections to the two inputs, the output could be made to switch from plus 6V to minus 6V when the level of illumination decreases. Other devices could also be fitted into the comparator circuit. For example, the thermistor could be used so that the circuit provides a warning for either high or low temperatures. And as we continue, we get to an example, in fact, two examples here. State what is meant by comparator circuit. It is a circuit that usually incorporates an op-amp. The output voltage of the circuit is either positive or negative, depending on which of the two inputs to the circuit is at higher potential. Example number 2, draw a diagram of a comparator that will give positive output when the intensity of the light incident on LDR is higher, and a negative output when the intensity is low.